Passwd is a tool on most Unix and Unix-like operating systems used to change a user's password. The password entered by the user is run through a key derivation function to create a hashed version of the new password, which is saved. Only the hashed version is stored. The entered password is not saved for security reasons. When the user logs on, the password entered by the user during the logon process is run through the same key derivation function and the resulting hashed version is compared with the saved version. If the hashes are identical, the entered password are considered to be identical, and so the user is authenticated. In theory, it is possible to occur the two different passwords produce the same hash. However, cryptographic hash functions are designed in such a way that finding any password that produces the given hash is very difficult and practically unfeasible, so if the produced hash matches the stored one, the user can be authenticated. The passwd command may be used to change passwords for local accounts, and on most systems, can also be used to change passwords managed in a distributed authentication mechanism such as NIS, Kerberos, or LDAP. Password file. The passwd file is a text-based database of information about users that may log into the system or other operating system user identities that own running processes. In many operating systems this file is just one of many possible backends for the more general passwd name service. The file's name originates from one of its initial functions as it contained the data used to verify passwords of user accounts. However, on modern Unix systems the security-sensitive password information is instead often stored in a different file using shadow passwords, or other database implementations. The passwd file typically has file system permissions that allow it to be readable by all users of the system, although it may only be modified by the superuser or by using a few special-purpose privileged commands. The passwd file is a text file with one record per line, each describing a user account. Each record consists of 7 fields separated by colons. The ordering of the records within the file is generally unimportant. An example record may be JSMITH, X1001 Joe Smith, Room 1007, 234, 555, 8910, 234, 555, 0044, email, JSMITH. The fields, in order from left to right, are username, the string a user would type in when logging into the operating system, the log name. Must be unique across users listed in the file. Information used to validate a user's password. In most modern uses, this field is usually set to X with the actual password information being stored in a separate shadow password file. Setting this field to an asterisk is a common way to disable direct logins to an account while still preserving its name. Another possible value is NP, which indicates to use an NIS server to obtain the password. User identifier number, used by the operating system for internal purposes. It need not be unique. Group identifier number, which identifies the primary group of the user. All files that are created by this user may initially be accessible to this group. Checkers field, commentary that describes the person or account. Typically, this is a set of comma-separated values including the user's full name and contact details. Path to the user's home directory. Program that is started every time the user logs into the system. For an interactive user, this is usually one of the system's command line interpreters. Shadow file. Shadow is used to increase the security level of passwords by restricting all but highly privileged users' access to hashed password data. Typically, that data is kept in files owned by and accessible only by the superuser. Systems administrators can reduce the likelihood of brute force attacks by making the list of hash passwords unreadable by unprivileged users. The obvious way to do this is to make the passwd database itself readable only by the root user. However, this would restrict access to other data in the file such as username to user ID mappings, which would break many existing utilities and provisions. One solution is a shadow password file to hold the password hashes separate from the other data in the world-readable Passwd file. For local files, this is usually shadow on Linux and Unix systems, or master Passwd on BSD systems. Each is readable only by root. Virtually all recent Unix-like operating systems use shadowed passwords. The shadow password file does not entirely solve the problem of attacker access to hashed passwords, as some network authentication schemes operate by transmitting the hash password over the network, making it vulnerable to interception. Copies of system data, such as system backups written to tape or optical media, can also become a means for illicitly obtaining hash passwords. In addition, the functions used by legitimate password-checking programs need to be written in such a way that malicious programs cannot make large numbers of authentication checks at high rates of speed. On a system without shadowed passwords, the Passwd file holds the following user information for each user account: username, salt combined with the current hash of the user's password, password expiration information, user ID, default group ID, full name, home directory path, login shell. The Passwd file is readable by all users so that name service switch can work, but only the root user can write to it. This means that an attacker with unprivileged access to the system can obtain the hashed form of every user's password. Those values can be used to mount a brute force attack offline, testing possible passwords against the hash passwords relatively quickly without alerting system security arrangements designed to detect an abnormal number of failed login attempts. Especially when the hash is not salted, it is also possible to look up these hash passwords in rainbow tables, databases specially made for giving back a password for a unique hash. With a shadowed password scheme in use, the Passwd file typically shows a character such as asterisk, or X in the password field for each user instead of a hash password, and shadow usually contains the following user information: user login name, salt and hashed password or a status exception value, for example, $@$salt $hashed. The printable form of a password hash is produced by crypt, where $id is the algorithm used, $5 is SHA-256 and $6 is SHA-512, crypt. 3. Man page. Other Unix may have different values, like NetBSD. Key stretching is used to increase password cracking difficulty, using by default 1000 rounds of modified MD5, 64 rounds of blowfish, 5000 rounds of SHA-256 or SHA-512. The number of rounds may be varied for blowfish, or for SHA-256 and SHA-512 by using, for example, $6 rounds equals $50,000. Empty string no password. The account has no password. The account is password locked. User will be unable to log in via password authentication, but other methods may be still allowed. LK or asterisk the account is locked. User will be unable to log in via password authentication, but other methods may be still allowed. The password has never been set. Days since epoch of last password change, days until change allowed, days before change required, days warning for expiration, days before account inactive, days since epoch when account expires, reserved. The format of the shadow file is simple, and basically identical to that of the password file, to wit, one line per user, ordered fields on each line, and fields separated by colons. Many systems require the order of user lines in the shadow file be identical to the order of the corresponding users in the password file. History. Password shadowing first appeared in Unix systems with the development of System V Release 3.2 in 1988 and 4.3 Bahamian dollars Reno in 1990. But, vendors who had performed ports from earlier Unix releases did not always include the new password shadowing features in their releases, leaving users of those systems exposed to password file attacks. System administrators may also arrange for the storage of passwords in distributed databases such as NIS and LDAP, rather than in files on each connected system. In the case of NIS, the shadow password mechanism is often still used on the NIS servers. In other distributed mechanisms, the problem of access to the various user authentication components is handled by the security mechanisms of the underlying data repository. In 1987, the author of the original Shadow password suite, Julie Hoare, experienced a computer break-in and wrote the initial release of the Shadow suite containing the login, passwd and su commands. The original release, written for the SE Unix operating system, quickly got ported to other platforms. The Shadow suite was ported to Linux in 1992, 1 year after the original announcement of the Linux project, and was included in many early distributions, and continues to be included in many current Linux distributions. In the past, it was necessary to have different commands to change passwords in different authentication schemes. For example, the command to change a NIS password was passed. This required users to be aware of the different methods to change passwords for different systems, and also resulted in wasteful duplication of code in the various programs that performed the same functions with different backends. In most implementations, there is now a single passwd command, and the control of where the password is actually changed is handled transparently to the user via pluggable authentication modules. For example, the type of hash used is dictated by the configuration of the PAM Unix SO module. By default, the MD5 hash has been used, while current modules are also capable of stronger hashes such as Blowfish, SHA-256 and SHA-512. See also, CHFN, CHSH, crypt, getInt, key derivation function, Unix security, VIPW. References. External links, manual page from Unix first edition describing PASSWD, PASSWD, 1, update to user's authentication token, S, a FreeBSD general commands manual, authconfig, a command line tool for controlling the use of shadow passwords, example shadow file showing the general layout of the file.